This is real time, Phil. We're actually seeing the day turn, right?
Yeah. So
Playing God a little bit. Hey, Phil, let's go to Indonesia. Do our last problem here. So click on my Indonesia pin, and here we are. You know, it kind of makes me feel like being a geography teacher.
it's quite fun, isn't it? This Google must really make a lot of great lesson plans.
Yeah, could be, anyways. Look at this volcano here.
Yeah.
A couple of volcanoes. Okay, so what are we gonna do?
Well, we're gonna start at position 1 as we've got set up there, and we're gonna travel on a bearing of 87 degrees for 25 miles.
87 degrees. Okay. For 25 miles. So I'll grab my red one. Make it 87. If you drag it longer, it's easier. Like if really short, it'll move really fast here. And the longer you make it, it'll be easier to get to exactly, what was it, 87?
87, yeah.
87.
And this problem today that we're going to look at is a little bit more complicated than the previous two. The students will need to use their knowledge of sine rule and cosine rule and non-right triangles today.
Right. Okay, so for how long?
Let's go for 25 miles.
25 miles. Okay. 25. Cool, it's way out there. 25, 25, 25. Pretty good, except I need to be on the red thing. Oh, I can't quite get there, can I?
Yeah, so we'll have to just extend that protractor a little bit.
Okay.
And places like Indonesia are really wonderful to do these activities because there's lots of islands and you can really play with some interesting bearing problems in areas where you could sail and the kids could think about sailing. Croatia is another great place to think about those problems as well.
Bahamas.
Ah, yes, good one.
Yeah, that's a good one. And don't forget the deserts. Some of the deserts are pretty good. You can be a lost, stranded person out in the desert, walking around. Okay, so then place my pin. I got the sail there. I measured it. Place my pin.
Okay.
Using my GPS on my nice big 60-foot yacht. Okay, position 2. All right, then?
Good. So now we're going to leave position 2 on a bearing of 238 degrees, and we're going to head for 35 miles.
238. 238-ish. It's pretty good.
That looks good.
And put that red dot in there. And for how long?
35 miles.
Let's grab the end of this one, hopefully. Doesn't like it, doesn't like it, doesn't like it. No. Alright. Start over. This ruler's a little finicky, and you gotta really just place it down. Click once, and I'm not holding down the click or anything. Okay, for what?
35?
35. I'm over on the 35. Put my projector back on. A little hard. Sometimes it's actually helpful to minimize or get rid of this in the options. Okay. 35.
That's good. Whoa, exactly. Well done. All right.
What is 35 in smoots, actually? Whoa, that's a lot of smoots.
That's a lot of smoots.
Dang, I didn't know. Did not know. Okay. Position 3. Good. Throw down that position 3.
All right. So now we have to pose the question to the students. How far are we as the bird flies from our original position? So let's head over to Notebook and see if we can solve that problem.
Okay, so get some of the stuff out of here. We've got left one of the things on there. That's okay. So we went from the start over here and then over here to position 3, and our question is from position 3 back to the start. So how long will it take me to get there? Okay, so what do I know?
That would be an interesting problem as well. Then we could add some kinematics and some speeds.
Ooh, that's not bad.
Okay.
calculus. Got 9th grade, 10th grade, 11th grade, 12th grade. Look at all this. Okay. So this length was
25 miles.
25 miles. This length is
35 miles.
35 miles. Okay, so this is going to be a little confusing here. So
let's first go the bearing from where we left. Do you want to put that one in first?
Oh, sure. Okay,
and
so
we left at a bearing of 87.
So this bearing right here is 87.
Mm-hmm.
Okay.
And then the next bearing we took was 238. So
okay,
from north around 238. This is a nice problem because it also brings in some of our knowledge of our parallel line theorems and transversals and things like this. All right.
Okay.
And now we can see that the two north lines are parallel, so we can fill in the angle 93.
Right here.
That's right.
93.
Good. And then we know the distance all the way around is 360. So 360 minus 93 minus 238 is 29.
29 degrees. Okay. So that was probably the hardest bit, right? Just getting some of these bearings.
Mm-hmm.
But just remember that just draw new axes every time you go somewhere, and the axes will obviously be parallel and perpendicular everywhere, and just kind of keep extending. And you've got, like Phil said, some of these supplementary and complementary angle and parallel line sort of properties. All right. So then what?
Good. So now this is that bit right there is probably the hardest bit that our students find, is they got to remember their theorems from before. But once they have it set up like this, they recognize that they have a non-right triangle. They have two sides, 25 miles and 35 miles. They have the angle between those two sides. So at this point, in the course, they know that that's a cosine rule situation. So then they can set up x squared equals 25 squared plus 29 squared, plus 35 squared minus 2 times 25 times 35 times cos of 29. Good. So that gives us 319, or so, yeah, x squared equals 319.4.
319.4.
Mm-hmm.
X equals?
So x is 17.9.
Now, another piece to remember is, do our questions or answers make sense? So when Phil said 319, I thought maybe he had put something else, but I knew that something around 17 or 20 or something seems to make sense. And of course, don't ever forget to go back to Google Earth. This is always the best part, and we get to measure these these lengths at the end. And what was our 17 something?
17.9. So you can see we're pretty much spot on.
Spot on. Google Earth did their job. Okay.
So did we.
So did we. Here we go. Okay. So good luck. Hopefully you can simulate some of these fun sort of activities in your class. I suggest keeping it simple and making sure that you reiterate to them that you're not allowed to measure anything unless you actually sailed there, and then everything else should be a-okay. Good luck.